Hello and welcome to this video all about surface area. Okay, so what is surface area? So surface area is the total area of all of the faces on a 3D shape, and it's demonstrated nicely by this little net of a cube here. So every face on a cube is 3 by 3. So 3 times 3 gives you 9, so that's one of the faces, and because on a cube we have 6 faces all of the same, we can do 9 times 6 to get 54, and that tells us that the area of every face added together is 54 centimeters squared. So this image here illustrates surface area nicely. So when we're doing it with a cuboid, remember we've got a lot of faces that are the same size. So if we look at this light blue colour here, we've got the top and the bottom faces, which are 8 centimeters by 5 centimeters. So remember 8 times 5 gives you 40. So we can do 2 times 40 there for that, which is 80. And then the purple faces here, which are the front and the back, they're 7 by 5, 7 times 5, which is 35, and we've got 2 of those, so that makes 70. The green faces here, which are the left and the right, they're 7 by 8, 7 times 8, which is 56. So if we times that by 2, we get 112, and then you can see at the bottom, when you add all of those together, that makes 262 centimeters squared. And remember, surface area, because we're dealing with area, it's in centimeters squared, not centimeters cubed like volume. Okay, let's take a little look at an example involving this cuboid then. So pause your video for this one, have a go. I'll use a calculator for this because there's a lot of sums, and then I'll have a look at the answer with you. Okay, so your first step here then is I've started with the front and the back of this cuboid. So that is 19 by 6, so that's this face here. So that's the front and the back. That's 19 times 6, so we've got 2 of the faces that are the same size there, which is why I've put this times 2 on the end. And that gives me 228. Then I've done the sides. So which the only one that's visible is this one here. We've got 2 of those though, because we've got the left and the right. So 19 times 4 times 2 will give you 152. Then we've got the top and the bottom. So we've got 6 by 4 there. So 6 times 4 is 24 times 2, and that gives you 48. And then if we add those up, you have a total surface area of 428 centimeters squared. Okay, let's have a look at another example. So if you pause your video on this one, have a go, and then I'll go through the answer for this one. Okay, so your front and your back is 13 by 8. So 13 times 8 times 2 gives you 208. Your sides are 8 by 5. So 8 times 5 times 2 is 80. Top and the bottom is 13 times 5 times 2. That's 130. Add all of those up and that gives you a total surface area of 418 centimeters squared. So now we're going to have a look at a slightly more complicated example. So this time we've not got a cuboid, we've got a triangular prism. So these are a bit trickier because you've not got as many faces that are at the same size. So it does involve a little bit more work. So why not have a go yourself first, have a look at this shape carefully, and then I'll go through the answer. Okay, so first of all here, you will notice it's called a triangular prism, and that's because at both ends of the prism, the front and the back, you've got a triangle. So if we do the area of one of those triangles, so if you just consider it to be the front there, we've got half times 5 times 12. Well, that's 30. But we've actually got two triangles. We've got the back as well. So if we multiply that by 2, we've got 60. So the area of just the triangular faces is 60 centimeters squared. Then we've got this slopey bit on this right angled triangle here. So we've got this bit here, which is actually a rectangle, as you can see. So we've got 13 by 10 for that, which is 130. Then we've got the base, which is 12 times 10, which is 120. And then you've got the side here, just here, which you can see the dotted line for there, which is 10 by 5, which is 50. If you add all of those faces together, so we've got both triangles there, which is your 60, and then you've got your slope, 130, your base, 120, and then 50 there. Let's get 360. Sometimes on the triangular prisms, they are sometimes shaped like this. So you might find sometimes that the sides are the same size if you've got them with a triangle like this, so a triangle that's not a right angle. So that's sometimes useful if you've got more faces that are the same. So bear that in mind on those ones. A slightly more complicated prism on this one now. We've got a trapezium based prism here. So your formula for trapezium, this is for 2024, this will be on the formula sheet, but it might not be after that. So that's half a plus b in brackets multiplied by the height. So that's the area of the trapezium, but it will not be on the formula sheet after 2024. So just bear that in mind. Okay, so pause your video, see if you can have a go first. Okay, so first of all, I'm going to deal with the trapezium. So this trapezium, the top and the bottom of it is 15 and 7. So that's your a plus b in the formula. So that gives you 22. Then I've done 22 times 6. I've halved that then, and that gives me 66 for your trapezium. Now we have actually got two trapeziums here. We've got the one at the front, the one at the back. So I've doubled that. And that's 132 for both trapeziums. Then we've got these two sides, which are both the same. So we've got this one here is the same as this one here. So I've done 5 times 8 for one of them. Then I've times that by 2 to get 80. Then I've done the top, which is 7 by 8, which is 56. So 7 times 8. And then your bottom, the base of it, is 15 times 8, which is 120. I've then got to add all of that together. So I've got the trapeziums here, and then I've got the sides here, the top there, and the bottom there. And that gives me a total surface area of 388 centimeters squared. Final example then here is we're going proper into grade 5 territory. These are quite tricky, these ones. They don't come up as often on foundation, but it's still a possibility. So I want to know the surface area of this cylinder. Okay, so we've got two circles here at the top and the bottom of the cylinder. So remember, the area of a circle is pi times the radius squared. So that's what I've done here. And I've got two circles. Now I've written this in terms of pi for now, just to make it easier to get all of those faces together at the end of our calculation. All right, you'll see why in a second. So that's the area of just the faces. Now the tricky bit here is the curved face around the edge of the cylinder. Now if you were to roll that out, it would look like a rectangle. Okay, so if you were to roll it out, you'd have the height of it, which is that 10 centimeters there, which is the height of the cylinder, and then you'd have this bit here. Now this bit here is going to be the circumference of the circle. So it's this curvy bit around the edge of the circle at the top and the bottom there. So remember, area of a circle is pi times the diameter, or pi times the radius times 2, which is what I've done here, because we know the radius is 7. Now that gives you 14 pi, so that's the circumference of the circle. So that's this bit. If we times that by 10, that then tells us the curved face area, so the area of that curved face. If we then add that to the area of the circles, that gives us 238 pi centimeters squared. So that's the area in terms of pi, which in some questions that's perfectly acceptable to write it like that. But if you type that in on your calculator, on your scientific calculator, that would give you 747.7 centimeters squared to 1 decimal place on this one. Okay, and that is it for this video. So thank you very much for listening. Please hit subscribe, and there'll be loads more videos coming your way. Thank you very much. Bye bye.